My name is Grier Johnson. I'm a site reliability engineer at, been that at a couple different companies, most notably LinkedIn, also a small internet company that you might have heard of named Yahoo, and then a couple companies that you probably never heard of, which is Responsys and OpenTV, and then a bunch of startups that all burned up and died. So for those of you not familiar with site reliability engineering, that's kind of a bunch of guys that stand on the front lines. They interact with a whole bunch of other people, things like the network guys, the developers, and things like that, and make sure that things actually work and run. So if LinkedIn's up and running, it's probably in no small part to the SREs at LinkedIn. In addition, I work for a particular group that handles some other things like monitoring. Monitoring's really important, as well as automation frameworks and various miscellaneous tooling. But the big question is, what does this have to do with Couchbase? What it has to do with it is that in my line of work, with monitoring, with a big site like LinkedIn, I need really fast access to data, and I have a lot of data to deal with. Specifically with this particular product right here. This is InGraphs. This is our internal data visualization layer. We slap it over top of a bunch of different metrics. And we really like pretty graphs. So we make pretty graphs with InGraphs that look a little bit like this. This is actually the graphs for InGraphs. So this is InGraphs graphing itself. We run 160 QPS just through the system, through API and user interactive calls. And we run a latency of sub 200 milliseconds to draw lots and lots of graphs for people. And we have lots of data in this system. We have 8 million unique metrics that come out of the systems for LinkedIn, which constitutes 16 million RRD files because we write everything out in duplicate, and that's 820K per RRD. You can do the math for that if you want to, or I can just show you this graph where you can see we're using almost 12 terabytes of data just to write out our metrics. So when you have all these RRD files sitting around and you want to find them, it can actually be really, really slow to, say, open a directory and look at all the contents of it because 8 million files take a long time to read over, especially if you have to check to see when they were last written, which we do since we write everything out in duplicate, and we need to know which one is the newest one. So we had to cache the location of these RDs. We needed some place to put them so that we knew when we need to find the location of something, we know where to find it right away, and it needs to be a fast lookup. So how it used to work is that we had these front ends, and they had their own local Memcache, and they had a way of talking to the storage nodes where all these RRDs were. And over the same basic interface, they would then try to find these RRDs. All these Memcache instances were totally independent. They did not share data. We didn't try to replicate data between them. And so each front end actually crawled all the available metrics and loaded them all in independently. And so it actually went through, it ran a stat on everything, and it kind of compared it to the replica, and whichever one was newer was the one that won to go in the cache. So we had some deduping going on there. And we did this all in memory, so you actually looked over 8 million files and took them all in a big hash and said, hey, which one's newer, and then kind of merged them all together. And then after that, we would take them and we would shove them into Memcache so that we could look them up later. So we built several indexes around this so that we could find things pretty fast. We built a all host key that had a great big list of all of our hosts in our system so that we could actually find out what hosts existed, because then we used the host names as a way of finding all the RRDs that were available for it. And so once you had that data, you could take those, and we actually did a hash of the host and the RRD name, and it would tell you where to find it. And so you did these kind of 3 lookups. The first 2, obviously, you could do every once in a while. The last one you did quite often because the metrics were always updating. And we did a hash of the host and the RRD name because we actually blew out the 256 character limit with just the RRDs. So we had to hash them out. Now, naturally, there are some problems with this particular way of doing things. First of all, data inconsistency. Each front end handled its own data. And so the data from one front end to the next might be a little bit different, which is a little disconcerting when you're refreshing on a graphing system and suddenly different data shows up. It makes you kind of wonder what's going on. It's also slow. We've been talking about that, going through all the directories and statting everything. Really, really slow. And so it kept getting slower and slower as we added more metrics, which is a problem. And additionally, I talked about how everything was in memory. So we did all this deduping in memory, and then we did a great big burst to write in the cache, and then we went back to reading all the files again. So it never kind of went in little bits and pieces. It just all kind of slammed it together and then tried to put it into Memcache as fast as possible, which is not a terribly efficient use of Memcache since it's idle most of the time, and it just kind of gets a bunch of data every once in a while. So we need to fix it. So what we decided to do was take the storage nodes and have them update the cache. So this meant that we had to move the cache centrally. We didn't want to have each storage node try to update every front end. That would be kind of ridiculous. And if we're going to move it centrally, we don't want the data to go away just because someone has to restart it or things like that. We want it to be up as often as possible. So we want it to be semi-durable. We can build the data set again. That's not a problem. But we don't want to have to do it over and over again. And we also want it to be fast. We have a lot of metrics. We have a lot of entries to update. We need to get it in there as quickly as possible. People add new metrics to our system all the time. So we want them to be able to see them as quickly as possible. So since people keep adding new stuff, it's going to get bigger and bigger. And so it needs to be scalable. And so along that line, we had some people that were testing Couchbase internally as a Memcache replacement. And so that kind of information got to me. And I said, well, Couchbase, that's kind of fast. That's kind of scalable. That's kind of semi-durable. Why don't we give that a try and see if that works for us? And so we decided to replace the local Memcache with a central Couchbase cluster. So we made it look a little bit like this. In this particular diagram, the purple arrows represent metadata updates with the storage nodes writing into Couchbase and the front ends reading from Couchbase. And then the black arrows are the actual metric gathering when they find out where stuff is. And this works. But the problem is that we found out wire speed really, really matters. We went from a local cache that sat on our box to a cache that was kind of spread out across different cabinets. And we also found out that because we got so used to having a local cache where there was no latency, we might make 50,000 queries to our cache just to render a single page. And if you add even just a little bit of time to a lot of queries, it can add up really, really fast. So what happened is this made the rendering of the pages really slow. Not to Couchbase's fault, but just to ours in the way that we architected everything. So we got what we needed, but it's too slow. So we need to figure out a way to make this a little bit better. So back to the drawing board. And we decided to do something a little bit more like this, kind of a combination of what we had been doing before. We brought back our local Memcache instances, but we kept our semi-durable, scalable, fast, super awesome Couchbase cluster in the middle there. So the storage nodes are still writing to Couchbase. They still do the same thing that they were doing before. So we're not traversing a whole bunch of directory structures. Each one is just kind of looking up off of its own and keeping track of that and writing in, so we can still scale horizontally that way. But then we added a loader on each of the front ends that kind of talked to Couchbase and stripped off a bunch of stuff it didn't need and loaded just the things that it needed into Memcache. So this is way faster. It's faster to load the stuff in the local Memcache than it was before, and it's faster because we don't have to worry about wire latency anymore. So we get to keep our central, durable, scalable store, and we get to have this 4-node cluster that is actually serving about 400,000 operations a second. We are just pounding this thing. Since we don't have to serve off of it on our front ends, and we really just want it to be like a data aggregation layer for us, we're just putting in data as fast as we can put it in. And it's really fast. In case you don't believe me, here's the graph off of our Couchbase cluster. We do not have a nice, pretty parabola, but we, in fact, have a nice line that just kind of sits up at the top. And this happens all day long, 24 hours a day, 7 days a week. And it's taking the punishment quite well. We load 16 million entries every 5 minutes. You can do that math, but that's the entry for where the path is and we'll talk about it in a second, but a time entry, some metadata around it. So even though we only want to know about 8 million metrics, we do have 16 million entries that kind of qualify it, plus the extra metadata about the host, but they're kind of a small chunk of it. And this is also, all this speed comes from using the Memcache compatible layer. So we're going through Moxi still. So we have a layer of indirection, and we're still managing to eke out this amount of speed. We actually did some tests with the Python client that suggested we could probably actually push 500,000 ops once you cut Moxi out of it and it's not handling the routing for you. So Moxi is our big bottleneck at this point in time. Couchbase can go much faster. Moxi is just having a hard time routing among the nodes. Not having a hard time, it's clearly doing quite well, but just it could go faster. So in addition to this, having a central cache that has all the data, it's allowed us to do a lot of interesting inspection. We've actually built some tools off of it to see what kind of metrics were on our system that we didn't have access to before, or we did, but it would be a little harder because we'd be kind of hitting one of our front ends, which we don't really want to do because they're already doing a lot of work right now. And so we can build a lot of interesting tools to inspect this data and figure things out. We maintain all these indexes anyways, so although Couchbase 2 might be a little nicer on that in the future. But it lets us get in there and just kind of see what's going on. And so this is pretty awesome right now. This is really fast. It keeps our data scalable. We can load a lot of data into it. We can read a lot of data out of it. And it's chugging along like a champ. And so interestingly, we kind of took Couchbase out of the critical path. We don't directly serve off of it. It's terribly important to what we're doing. But we could take it down if we needed to. Those local Memcache instances give us about 12 hours of slop if we had to do anything crazy with Couchbase. But what Couchbase does give us is the routing and no hashing magic, and it gives us the ability to kind of scale really easily, which would be a little bit harder if we were just trying to do a direct Memcache or something like that. And it let us continue using Memcache. We were still able to use a lot of the code that we already had sitting out there. Let us continue using Python, which was important to us. We use Python as SREs at LinkedIn. And we can kind of, in the centralized area, we can take our storage nodes that have certain metrics out of rotation just by saying, don't load into the cache anymore. If they don't load into the cache, the front ends don't know about them. You don't have to take them out of each individual front end. It's all one central place. And if they don't talk to it, they're not there anymore. And this helps us do maintenance on our back-end systems. So our cache loading time dropped from about 30 minutes when we first started this project to about 5 to 10 minutes right now. There's a little bit of slop because it does 2 loads. It's about 5 minutes to load into Couchbase. It's about 180 seconds to load into Memcache. So it kind of just depends on how those line up. But it's significantly shorter, and we have a lot happier customers right now. And the front ends are more consistent. They have a smaller window where the data is different, and they all load off of the same place. And they all load pretty much as fast as possible. So they catch up and are consistent much more often than they were before. So you don't get the disconcerting thing where you reload and suddenly your data is totally different. That's not to say it's without problems. So a consistent and durable cache. So before we were able to just turn off the cache on the front end and bring it back, and it would just reload, and we would get back to where we were before. Now we have this nice, consistent, durable cache, which is something that we wanted, but we realized that now there can be bad data in the cache, and we have no way to get rid of it. So we did have to build a lot of tools for cleaning that stuff out. So the same kind of tools that we were using for inspection, we just kind of said, well, instead of a read, why don't I just delete it when I find it? So we did that. That was kind of cool. When you're hammering Couchbase like this, we're totally unforgiving in the amount of traffic that we're throwing at it, so the rebalances can be a little slow. That being said, we don't serve off of Couchbase, so we're able to stop the loaders, drop the traffic to nothing, and we do rebalances really, really fast, add nodes in and out, and we can do them pretty quickly, about 15 minutes, just to copy all the data around. The other thing that we had that was interesting, the Python native client is not complete, and so when we first started this project, we tried to use it, and it kind of didn't quite work for us. That's why we're on the Memcache compatible API. But a lot of the newer versions of it are a lot better, so we plan on kind of migrating over to it to bypass Moxi, get some more performance out of the number of nodes that we have, and free performance. Who doesn't want that? And then we found out that distributed data is kind of hard. We have 20 writers going into Couchbase, where the code that we initially started with only had one writer talking to one cache. So we added a lot of extra metadata into our cache so that we could figure out how things were working. For example, we added, the same way that we add a hash of the host in the RD, we now have a time key for it. And it stores the last update time, the mtime of the file itself. The reason we didn't add this in and create like a hash structure around the key value of the other one is when we're ripping things out of Couchbase and loading them into Memcache, we want to do that as fast as possible. So we don't actually want to decode a lot of the data there. So we kind of used a lot of performance tweaks to only have the minimal data set available by itself that we planned on loading into Memcache. But this lets us store the time so we can kind of do an inspection of the last time it was updated and only do an update for the metric index if we actually need to. Additionally, all those lists that I talked about, they're dictionaries now with the last seen time. So the last time we saw a host, the last time a host saw this RD, things like that. So we can keep track of those and flush out that data as it goes along, because we kind of have to keep this consistent data view. So we want to pull stuff out, update it, and put it back in, but we're not totally sure if someone else saw the data at any point in time or another. So we have to keep track of the last time anybody saw the data so that we can rip it out as it ages out of our system. Some other problems we ran into is that the Memcache API makes multi-key atomic transactions impossible. So you can see I have a lot of stuff broken up into multiple keys. So I can't actually ensure that the time key and the path key get updated at the same time. So this was a bit of a problem because multiset is not atomic. They don't necessarily come right out and tell you that, by the way. But it's not an atomic operation. You set multiple keys, it'll actually just come back and tell you, I couldn't set this one, sorry. But all the rest, they're cool. So what we wound up doing is having to write a lot of cautious eventual consistency into our system. We want to make sure that we'd rather not have the path for our metrics in the system at all, rather than have a really, really old metric accidentally show up into our system. Because then you get no data, which is even worse than that slightly different data when you hit refresh. So that was kind of how we put Couchbase into our system. We found out that it really kind of worked for us. It would have been nice to be able to serve directly off of it. However, that was kind of our fault, not Couchbase's fault. I'm interested in Couchbase 2.0. I learned a lot of interesting stuff about it here. I don't think it works quite well for this because we were basically just, how do we replace Memcache with something that's going to work for a large distributed data set that works really, really fast? So that's pretty much all we really did. Not too crazy. So yeah, just want to let everyone know we're also, if you like what we're working on here, we're hiring. You can come work for us. You can work on Couchbase. It'll be cool. But other than that, that's all I have. Any questions? The question is what kind of hardware they are. They're 12-core Xeons with 48 gigs of RAM in them. We actually only use a 16 gig per cluster allotment. So it's not a whole lot of data. The keys are actually quite small, which is how we can kind of get that performance level that we're working at. But we do need to load them all the time. So if I remember correctly, they run at 30-ish% CPU. So they're not heavily loaded at all. I think Moxi is just kind of topping out on where we're doing server-side Moxi. We could probably break it out and get a little more performance out of it. But it's kind of nice to just install the Couchbase server RPM and go with it. So the storage layer, so the metrics are actually stored on very similar machines, except they're stored on SSDs. So I mean, we have, each one stores 600,000 RRDs apiece, and so we decided to go with just individual RRDs that represent a single metric, and then the SSDs gave us essentially infinite I/O. We run a couple 100,000 IOPS through those as well. So just standard GigE. Yeah, so we do a standard core switch with rack layer switches as well, with patch through. So there's nothing particularly special about what we're doing. The Couchbase servers are, I don't think they're in the same rack, but they're in racks that are, they may actually go back to the core switch. I'd have to double check on that. But Well, I mean, it's just my index right now. I mean, but yeah, if we ever move to a serving model, it might be interesting to do something like that. But I mean, TCP adds its own latency. There's only so much you can collapse down into it. Yeah, actually, so the RDs come from a legacy system where we actually lived with 2 metric systems at the same time. One spit out only RDs, and so we kind of built the second one around RDs. We're actually doing a collapsing project where we shut down the old one, and we're trying to we're evaluating new backends for where we're going to store all the other metrics. So Couchbase is on the list of stuff that we are planning to evaluate, but we have a whole lot of other options as well that we're just going to try to see which one is the right one for us. Anyone else? Cool. Thanks, everyone.